and I want to minimize this state table. And the nice thing with Dr. Trahan is he doesn't make you like try all the different possibilities. When you make an assumption, you can just assume that your assumption was okay, and you don't have to go back and see if it would have been better if you'd made another one. It might be, and if you were really trying to do this to cut costs or something, you'd probably want to try more than one, but you don't have to do that. So the first way that we break these up, well, our first partition will be all of them. And then our next partition is to break them up based on outputs. So our possible outputs that we have so far are 1, 0, 0, 1, and then we have an incompletely specified, so I'll leave that out, a 1, 1, and a 0, 1. So I know that B and F have to be together. And I know that D is going to be in any group that has 1, 1, and A is going to be in any group that has 1, 0. Then I just need to decide what to do with C and E. And so my instinct, well, I don't know what would be best. If I made them both zeros, then one would go in, if I made this 0, I think I want to make this one 0, because then I can put C up here. And I'll make this one, I just look over here and I notice, I see right away that D has a 0 successor of A. This one's incompletely specified. I see if I do this, I don't have to worry about E anymore. I know E and D are going to be together forever because they have exactly the same outputs. So I'm just going to go ahead and do that because that just makes it easier for me. And now I have A, B, C, D, E, F. I know I don't have to do anything with A because it's all by itself. D, E, I've made those so that they're good. So now I just need to look at B, F, and C. So let's see. So B has as its 0 successor F, which is in the first group. F has as its 0 successor B, which is also in the first group. And C is incompletely specified. Well, while I don't have to make this as efficient as possible, it sure would make sense to keep it in the same group, so I'll just make it F. And now these stay together. So I have B, F, and C, and D, and E, and A. So now I still need to look at the 1 successors. The 1 successor of B is D. The 1 successor of F is also D. And the 1 successor of C is E, which is in the same group as D. So they're also in the same group. And so P3 is going to equal P2, and so I'm done. Okay, does someone want to suggest another problem? I think I can do one more.
Did you read the 9 or 10?
Mm-hmm. Oh, I should probably do an ASM chart, because I haven't ever done one of those. Maybe I'll do 9 and maybe I'll do 10, and I'll probably do both 9 and 10. I'll start with 9. Okay. y1 and y0 are the present state variables. Capital Y1, capital Y0 are the next state variables. We want to analyze these to derive the next state expressions and the output expression and construct the corresponding state assigned table. Okay, so we have that y1 equals little y1 and not little y0 and y0 equals a and not y0 and g equals y1 and y0 all right. So if I had does the output depend on our input? No, because our only input is A.
What does y0 not from y1?
Say that again?
Why is there y0 not?
Okay, because here's y1, and y1 is the and of y1 and the not of y0 because it's coming out of the Q bar. Okay, so my next state, notice for so for y0 it equals the and of A and y0 not. So when A is 0, this is going to be 0 all the way through. So I'm just looking at this and using y0 and y1. When A is 1, it'll be 1 and y0 not, so it'll be the not of y0. y1 is the and of y1 and y0 not. I'm going to just do this for myself because I can't keep too many things in my head without. I just made a little column of y0 not just so I can see it. So y1 is y1 and y0 not. So that is only going to be 1 in this case. And it'll be 0 everywhere else. And G is the and of y1 and y0. So So that'll be 0, 0, 0, 1. And that is my state assigned table.
You can put big Y 1 or big Y 0 first, it doesn't matter.
You can, yeah, you can. Different computers have different conventions for that, and Dr. Trahan usually puts Y1 first, and so when I'm doing his SI, I try to do it that way. The other professor does it the other way, and I forget. But no, there's not, it, either way is fine.
Okay, thank you.
Other questions? All right, so I did want to do one ASM chart since I had never done one with y'all, but if you've taken any computer programming at all, which you have, they're not bad at all. So for this one, it says from the given state table, construct an ASM chart. So I thought for me it was easiest first to do a state diagram. So I had A, B, and C. And my output for A was 0, and for B was 0, and for C was 1. And for A, if W was, well, for all of them, if W was 0, you go back to this, no, you go to A. And if W is 1, if you're at A, you go to B. That's not B. Try this again. Forget all that. A, B, C. 0, 1, 0. If it's 0, you go to A. If you're A and it's 1, you go to B. If it's B and it's 1, you go to C. And if it's C and it's 1, you stay at where you are. Okay, so we'll represent our states with little rectangles. So this will be A, and I'll put my output on the state. I can say Z equals 0. And from each state, I will make a decision, and I will make a decision based on the value of my input W.
It's easy one for the last one.
Thank you. And for state A, if W is 0, I go back to A. Put a little 0 there. And if W is 1, I go to B. And for state B, if W is 0, I go to A. And if it's 1, I go to C. And for C, if W is 0, I go to A. And if it's 1, I go back to C. I think that's it. All right, so that's it. I'm actually going to just sit here and continue recording. I'm going to do the last one, so if you want to stay and just watch while I'm doing that, that's fine. I just figured while I had it
Last
open.
one?
Yeah, I'm going to do number 11, so you're welcome to stay for that if you want, but if you want to go, my feelings won't be hurt. So I'm just going to go ahead and do that, unless there are any questions. All right. So now I'm just kind of talking to myself, so I'm just, since I have this out and recording it, so I don't have to do it later.
Thank you.
You're welcome. Bye. So I'm doing the ASM chart. I see I've got 3 states, S0, S1, and S2.
Thank you.
You're welcome. Bye-bye. And I decided on this one, I don't know why I didn't decide on the last one, that I wanted to make this the reset, so I'll put a reset here. And this one is mealy, so I don't put my outputs on the states. I'm going to put my outputs in little ovals. And so for S0, I make a decision, and the decision goes in a diamond. And I just made up a variable name for that. That's 0. And if W, if W is 1, I go to S1. And if W is 1, my output is 1. So I'll have an oval, and I don't know what the output variable name is. I'll call it Z. Z equals 1. And that, so when W is 1, my output is 1, so I get that as an oval, and then I go to state 1. And when W is 0, my output is 0. And I go back to state S0. From S1, if W is 0, I stay in S1, and my output is 1. I should have put a 0 up here on that decision. And then if W is 0, I go to state 2, and my output is, oh, I got that backwards, huh? Yeah, this should have been W0. Yeah, I got that backwards. And when W is 1, my output is 0, and I go to state 2. And from state 2, if W is 0, my output is 0, and I stay in state 2. And if W is 1, my output is 1, and I go to S0. It's not the most organized of ASM charts, but it is an ASM chart. And I would have been Much better if I had like done my decision trees like symmetric, like 0 on the same side on all of the little diamonds, but
Is
I'm
that
not that
what
neat.
one of the-
Yes, it is. Thank you. Any questions? All right. I'm going to stop this, and if there's anybody left in this, oh, wait, there's a chat. Hold on. Let's see what that says. Thanks. Oh, okay, you're welcome. Okay, let's see if there's anybody left in the Zoom, and I am going to call it an evening. Except I'm not. Are you coming back for circuits too?
No, I gotta go pick up my kids.
Okay,
But
all
I'll
right.
be on the Zoom.
Okay.
I should be home by that time.
All right, okay.
5:30.
5:30, yep.
All right.
Okay,
Thank you.
you're welcome.